Okay, welcome everybody. So another live stream. What I want to do in this one is cover some binomial expansion. And what we're going to really kind of look into is just looking at a couple problems where we're going to expand completely. And then what we'll do is we'll look into just how to find a given term in a binomial expansion. And then what we'll do is we'll work into some multiple choice questions, how to kind of address this problem when you're given like a multiple choice problem. And then we'll do 3 of them. And then there's some think about it ones at the end. So this live stream should hopefully, take about 20, 30 minutes. And then for those of you that were on my live stream before, you'll notice that I'm going to be coming back live here again in about half an hour. So I'll just take a little break once I wrap this one up. And then I will come back and we're going to do a second homework assignment. So this is a homework assignment that I did give to my students for them to kind of work on. And the reason why, again, I'm going live for those of you that are, now coming in is I like to kind of cover the solution so I can provide them to them. And then obviously providing the live stream is a way for, me to kind of give it a little bit of instruction. And for those of you that are kind of watching this on the replay, obviously you can kind of see, how I'm working in through some of these problems. Just kind of give you also a little baseline. What I'll do is I will work through basically these first 2 examples straight through. Then I'll take a little break, check in on the chat, see if there's any kind of questions that any students have, and then what I'll do is I'll finish through the multiple choice. If you do end up coming on the stream and you have some questions that you're in your own math class, feel free to go ahead and add them into the chat, and I'll be more than happy to answer them when I get to it. So without further ado, let's go ahead and get started with binomial expansion. Now, obviously, when I'm covering homework, I'm not going to cover everything from the beginning. I'm really just going to be, this is assuming that you've gone through at least the basic lesson of the binomial expansion. And a couple of things that we talked about with binomial expansion is we actually multiplied these out, on our own just by using distributive property, and to go ahead and recognize the patterns that we had with the binomial expansion. Then we also did is we looked at the coefficients and the patterns with the coefficients that gave us the Pascal's triangle. So first thing we're going to do, let's just go ahead and start off with just a regular expansion. Now, the main important thing, one thing we talked about, we did look at problems where we have a negative as well as a coefficient. And I think it's really helpful when we're doing a problem like this to rewrite the expression as x plus a negative 2y. So using these parentheses to make sure that we are going to be using each and every term, raising it to the correct power. Because a lot of students will just take, this 2y and raise it to the 5th power, but you got to make sure you take the 2 as well as the y. So following with our understanding of the binomial theorem, noticing that the first term always starts with the power of your expansion and then goes in descending order. And the second term always starts at 0 and then goes in ascending order. So leaving a little space for the coefficients, I'll come to that next. But the first thing, let's tackle our first term is going to be x to the 5th. And then I'm just going to write this in there so we can kind of see it in action, is negative 2y to the 1st. And then plus the next term is going to be x to the 4th. Again, we're going in descending order. So therefore, then the next one is negative 2y to the 1st plus x cubed, negative 2y to the 2nd plus x squared, negative 2y to the 3rd plus, let's see, it's going to be x to the 1st. So I'm going to write x to the 1st so on this one just so we can kind of see. I don't know why I'm using parentheses. That's where I got mixed up. I could use parentheses for the x's, but it's not really necessary. Oh, jeez. Come on. Live stream always. All right. X to the 1st times negative 2y to the 4th. And then the last but not least final term is going to be x to the 0 and negative 2y to the 5th. Okay, so it's important that our first term starts with phi, and you can see that it goes 5, 4, 3, 2, 1, 0. And our last term, which can be rewritten as negative 2y from here, is going to be negative 2y to the 0, 1, 2, 3, 4, and 5. All right. Now, obviously, we can simplify this, and once I start doing some more problems, I'm not going to show all of these steps, but I want you to kind of see where these steps are coming from. Now, the next thing is identifying the coefficients, and that's going to come from the lovely Pascal's triangle, which I'll go ahead and create here with let's use orange. So Pascal's triangle is something that we looked at with the expansion. Okay, and what we did is when we have any binomial expanded to the 0 power, the coefficient was always 1. When we took a binomial expansion raised to the 1st power, the coefficient of my two terms was always 1 and 1. When we took a binomial expanded to the 2nd power, what we found that the coefficients were going to be 1, 2, and 1, or at least a multiplier of the coefficients were 1, 2, and 1. And then what happened as we kept on doing this, we actually started to see a pattern within Pascal's triangle itself. What we notice is that each consecutive terms, when you add them, they give you the next term down below. So 1 plus 2 is 3. 2 plus 1 is 3. So what we started doing was, well, we're like, we don't need to keep on multiplying this out. We can just say 1 plus it. Each term is always going to start with 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then ends with the 1. And now I'm running out of space, so I'll at least do to the 5th power. I'll do that down below. So we'll have 1, 5, 10, 10, 5, and 1. Okay? And I think I'd probably get up to the 6th power or 7th power, so we'll add those in there as they come up. Let's do the 6 because we have that in the next example. Oops. So if we raise something to the 6th power, then again it's going to start with 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 15, 6, and 1. Okay. All right, so that will at least get us started here. And what you can see is this is to the 5th power. So therefore my coefficients, all right, are going to be a 1. So let's erase that up there. So we'll have a 1 times a 1 here. We're going to multiply by a 5. Here we'll have a 10. Another 10 in front of this term. Another 5. And another 1. So you can see that even though it's raised to the 5th power, there are 1, 2, 3, 4, 5, 6 terms. And now basically all we need to do is really kind of like simplify our answer. Negative 2y to the 0 is just going to be 1. So therefore we can just write this as x to the 5th. All right, we have negative 2y to the 1st, so that's just going to be negative 2y times 5 is going to be a negative 10. X to the 4th, y. Over here, we're going to have negative 2y squared. So remember, any negative number squared is going to be positive. So that's going to be 4 times 10. So that would be positive 40 x cubed y squared. Here we're going to have negative 2 cubed. That's going to be negative 8 times 10, which would be a negative 80. And that would be x squared y cubed. Here we have negative 2 to the 6th power, which is going to be 16. 16 times 5 is going to be 80. And then again, remember, that's a positive 16. So that's going to be another positive 80. And then x, y to the 4th. And then over here we have negative 2y to the 5th. So negative 2 to the 5th power is going to be a negative 32. Y to the 5th power is y to the 5th. And then x is 0 is 0. So therefore we'll have a negative 32 y to the 5th. And there we go, expanded. Much quicker and easier than actually multiplying this out. And obviously you could use combinations to go and write this, but this is just the way that we've discussed this for this class because we don't really get into the much more of the work with the binomial theorem. All right, so in this next one, let's just go ahead and follow again the exact same patterns. Obviously, we're going to have the first term is going to be raised to the 6th, second term is going to be raised to the 0 power, and we're just going to go in descending order. So we have x to the 6th, 1 to the 0, plus x to the 4th, 1 to the 1 squared. Now, I'm not going to use, let's write that up. I'm not using parentheses, though, so hopefully you can kind of see we don't get too stuck here. Plus, let's see, this is going to be x to the 3rd, 1 to the 3rd. Plus, oops, I got to leave myself some space, don't I? Let's just leave a little space for the coefficients. So x cubed, 1 cubed, plus x to the 4th. No, that's x squared. You got to go in descending order, 5, 4, 3. So this is x squared. Jeez, sorry about that. That's x squared, and that's going to be 1 to the 4th, plus x to the 1st, 1 to the 5th, and then plus x to the 0, and then 1 to the 6. And again, you don't need to write all of these out, but I just wanted to, write them in there so you can kind of see this pattern that we're creating. Now, you can see that we have an expansion to the 6th power. There are 1, 2, 3, 4, 5, 6, 7 coefficients, and we have 1, 2, 3, 4, 5, 6 coefficients. So I made a mistake. This is supposed to be to the 6th power. Great. So I forgot about that. Perfect. So let's go ahead and fix these. So these are all wrong. Good job. Oh, that one wasn't. So let's go ahead and let's put a line here so I don't mix this up. So this is going to be, oh, geez, oh man. Oh, I know what I can do. Why don't I let's go ahead and move this over. There we go. Sweet. So now let's do x. Oops. Little technical difficulties here. Sorry about that. So let's see. We're going to have x to the 6th, 1 to the 0 power, plus, this would be x squared. This would be x cubed. That's to the 4th. That's to 6, 5, 4, 3, 2, 1, 0. 0. I'm like losing it, man. What the heck? I guess this is what happens when you teach all day and then go ahead and try to live stream. So this is x to 0. This is x to the 1st, x squared, x cubed, x to the 4th, x to the 5th. I'm sorry, not x, 1 to the 6th. So we're doing the ones, which again, we don't really need to write those in there. I'm just showing this again for, at least you can see, because 1 raised to any power is always going to be 1. Now let's go ahead and throw in these coefficients, which are going to be a 1. And again, remember, these are all multiplied. 6. We're going to have a 15. We'll have a 20. 16. 16. What am I doing? I got to slow down. 15. 6. And then a 1. Okay, but the main important thing that I wanted to show is, I showed all these steps and everything coming in here. And you notice I obviously made some mistakes, but I recognized some mistakes by making sure that I knew that my first term was always going to be raised to this power. My last term, my 1, had to be raised to that power, and the first term goes in descending order, the first term goes in ascending order. If you have a binomial expansion raised to the 6th power, you're going to have 7 terms, you're going to have 7 coefficients. So everything's going to have to match up. So let's just go and write this answer here. X to the 6th plus 6x to the 5th. Plus 15 x to the 4th, plus 20 x cubed, plus 15 x squared, plus 6 x, and then plus 1. And you can see this one's rather nice, right? I mean, I expanded this to kind of do a little bit of instruction, but you can see this one worked out fairly nicely because we had the number 1 and an x with no coefficient. So kind of nice for there. Now what we're going to do is just kind of work on the third term of finding the binomial expansion. And what's nice about finding the third term is we don't have to find every single term. We just have to find, did I do that the same? Yeah, I did. We don't have to find every single term. We just have to find the third term in the expansion. So like, for instance, that's the third term. That's the third term. So from the left, we want to find the third term in. All right. So the main important thing, though, is we want to still set up our expansion the way that we have done before. Basically here, we're going to have our first term, 3x raised to the 4th, and our second term is going to start at 0. And then the next term is going to go from 3x cubed, and our second term would be 2y to the first. And now our third term, I'm going to leave space for my coefficient, is going to be 3x squared, and then we're going to have 2y squared. Now I got to look at this as the expansion to the 4th power, so I want to see what is the coefficient of that third term. So I'm going to go back to my Pascal's triangle, and I see the expansion of the 4th, which is 1, 2, 3, 5 terms. You can see that the third term has a coefficient of a 6. So that is going to be the coefficient that I'm going to enter in here. And then now all I need to do is simplify. Okay. So let's see here. We're going to have 3x squared is going to be a 9x squared, and then 2y squared is going to be a 4y squared. All right, now we just need to multiply all of this out. So 9 times 6 is going to be 54, times 4 is going to be 108, so 216. Hopefully I'm not doing my math in my head wrong, but 216 x squared y squared. And that would be what we are looking for in that example. That is going to be the third term. So rather than doing the whole expansion, we just want to find the third term. All right, in the next one, kind of like the first example I did, we're going to want to write this as x plus negative 2y to the fifth. It just helps make everything else cleaner. I'm going to use blue this time. So therefore, my first term is going to be x to the fifth. And then this would be negative 2. Let's skip it. It's going to be negative 2y to the 0, right? We know that. All right, so the next term is then x to the fourth and negative 2y to the first. And then my third term is going to be x cubed and then times negative 2y to the second power. All right, you can see that's always going to be to the second power for that. So now let's go ahead and figure out the expansion here for Pascal's triangle to the fifth power. And you can see here the third term here is going to be 10. So now I'm going to place a 10 here as my coefficient. And now I just need to go ahead and simplify this. So negative 2y squared is going to be positive 4y. So therefore I have a 10x cubed times 4y. And 4y times 10 times x cubed is going to be a 40x cubed y. All right, now let's go ahead and get into, wait, that's squared. Don't forget the squared. That's 4y squared, right? Sorry about that. All right, now let's do the last expansion, which is x plus y to the sixth. And then once I'm done with this example, I'll take a break. If you guys have any questions coming up in the chat, then I'll be more than happy to see what I can do to help you out from there. So all right, let's go ahead and use purple for this one. So again, we're just looking for the third term. So this one's kind of nice because we don't really have any coefficients. So, we have x to the sixth, y to the 0, plus x to the fifth, y to the first, plus x to the fourth, y squared. And you probably don't even need to write those. Hopefully, by the time you get really good at this, you can kind of start to skip some of those steps and get right to here. But then we want to look at the expansion to the sixth power on Pascal's triangle. The third term is going to be a 15. So therefore, I will write a 15 in there. And there's really no more math that I really need to do here. So therefore, my answer, my third term, is 15x to the fourth y squared. So there we go, guys. Now what we'll do is I'll just take a quick little break and I'll get into the multiple choice questions. If any of you are following along with this and you want to try some of the multiple choice questions on your own, I will leave them up on the screen as I just kind of take like 1 or 2 minutes just to kind of check in. So you guys are doing that are in the chat. So Communication. Honestly, I think math was created by Satan. Yeah, I know. I mean, it can be crazy at times. And trust me, I know exactly how you feel. I've struggled with math, and I've done a lot of math problems. And I always joke with my students. I'm like, think about like you guys hate math class, right? Or you struggle with math like you do, you take one math class. But I'm like, think about me. Like I'm doing math literally all day. Every single day I am teaching math. Every single class I'm doing math problems. Like obviously I try to make my students do as many math problems as in class rather than me always doing it. But still, I'm doing math over and over and over. Then, I'm staying after school, doing live streams, doing more math. Then I go home and I'm grading. I'm creating lesson plans. I'm doing more math. And it's like, I'm like immersed with math, or like immersed with math. And there's good and bads with it. Obviously, like, it's almost like too much. I'm like, oh my God, I need a break from this. But in the same respect, I've gotten really good at doing a lot of operations, which you can tell, which really speaks to the fact of like the more practice you do, the better you are going to get at math. And it doesn't matter, what you're trying to, work on, but the more you can build up those essential skills, the better you're going to be. And the better foundation that you have in math, the easier it is for you to grasp the more difficult concepts. And that's, I think, a lot of what students struggle when they start to get into upper level mathematics is they don't have that foundation. For me, that was the case. That when I started taking my college classes, that's where I struggled because I didn't have a strong foundation. So I could understand stuff, but I wouldn't really understand why things were working out. And that was because I didn't have a good foundation. So I get it. That was a really long comment for you. But anyways, there we go. Let's see. Blitman, can you help me with graphing a parabola with 2 points? Is there an easier path without the quadratic formula? Yeah, Blitman, if you can, Blaine, if you can give me a question as far as what question you're kind of working on. I'm assuming you have 2 points as far as given like the vertex and a point. I can definitely help you out with doing that problem. I am going to have to wait till after my live stream though, but I can definitely help you out with that. Hey, Demedge, I need help. Well, let me know what your questions are. I'm going to go ahead and get onto the I'm going to get onto the multiple choice questions now. But if you guys have any questions as far as in your own classes, just go and type them in the comments. Once I'm done with this live stream, I will take about 5 minutes to go over them. And then what I'll do is also go into a break, and I will be coming back live here in probably like, I don't know, 4:15-ish to finish up another homework on zeros. So, all right, let's go ahead and work on the binomial, some multiple choice. So here we have use the binomial theorem to expand. Now I'm just going to use binomial expansion the way that I have been teaching in the class. I'm not actually using the formula for the binomial theorem. And what we have here is we basically just want to expand 2x minus y. And the important thing is we don't really need to expand this completely, because all we really need to do is figure out, you can see here, the first two terms, like once we find the first term, you can see that two of the problems are not the same, right? And then once we get to the second term, we basically just need to find the first two terms. So let's go ahead and do that raised to the fourth power. The first thing I'm going to do is I'm going to take 2x and I'm going to raise that negative y to the fourth. So I know my first term is going to be 2x to the fourth times negative y to the 0, and then plus 2x cubed times negative y to the first. Now for the coefficients, I need to go back up to my binomial expansion. You can see my coefficients there are going to be 1 and 4. Whoa. So I'm going to have a coefficient of 1 here and 4. All right. So I have 2x, 2 raised to the fourth power, which is going to be 16. So that's going to be a 16x to the fourth. So obviously you can see that B and C are not answers, right? So now I got to see, oh crap, I did have a 32. Oh, and you can see one's negative, one's positive. So let's see which one is going to work. I have 2 raised to the third, 2x raised to the third power, which is 8x cubed. So I have 4 times 8x cubed. And then negative y to the first is just negative y. And what you see is if you were to multiply these out, you would get a negative 32. So therefore my answer is A. Use the binomial expansion to expand x plus 2y to the fourth. So again, what we need to do, looks like we need to get to this third term here because a couple of them share the first and the second. So we need to get to that third term. So let's go ahead and do that here. So we'll do x. Well, we don't need to rewrite it out. I'll just write x to the fifth is the first term because it'd be 2y to the second, and then plus x to the fourth, 2y to the first, and then I need to at least get to the third term. So that's going to be x cubed. I don't know what number I was writing there. 2y squared. All right, and this is to the fifth power, so I need to make sure I go back up to my Pascal's triangle, look to the fifth power. That's going to be 1, 5, 10 are the coefficients. So I have 1, 5, and 10. Okay, and now let's just go and simplify. So this is x to the fifth, which they all have. This is going to be 2y to the first, so that's just going to be 2y times 10, so that's going to be plus a 10 x to the fourth y. Well, actually, second term, no, never mind. We didn't need to do that. The second term, these ones are unique. So guess what? I got my answer right there. Done. Find the coefficient of the third term in the expression 2xy to the third. So now they're asking us exactly for that third term. So what we're going to have to do here is expand this to the third portion. So we'll have 2x. Let's see. Well, that's going to be to the fifth, y to the 0, plus 2x to the fourth. So that means my third term is going to be 2x to the third. This would be y to the first, so therefore this would be y squared. And now I just need to remember to the fifth power. This is to the fifth power. My third term is going to be coefficient will be 10. You could also confirm that on the binomial expansion, or Pascal's triangle, I'm sorry. 2x cubed is going to be 2 times 2 times 2, which is 8, times 10, which would be 80. X cubed, y squared. They're just looking for the coefficient. You can see 80 right here. And so there you go. And obviously, guys, if you want to have a little fun with some binomial expansion, you can work on these two problems, which, I'm not going to go over because I want to end this. So let me go and see if you please do a literal equation problem. If you can respect the gap, if you can give me any question that you want me to do, I will try to do my best here. But I am going to want to sign off here in probably like the next couple minutes for you guys, to make sure that I can take a break and then come back. But I will be coming back in the next, 10, 15 minutes. So if that is something that you guys are interested in finding the real zeros of polynomials, that is what I'm going to cover next in the live stream. But I just need to take a little break, and obviously you can hear my voice is a little raspy and stuff like that. So I will follow the same format though, as far as go ahead and working through some problems, kind of do some free response, and then I'll get into the multiple choice, and then obviously any questions I have after that. So, I think that's about it. I'm going to go ahead and take a break unless I get any kind of questions for you. But again, guys, if you just want to, make sure you check back in. Oh, let me go and look into the schedule. Let's just see what's coming up as far as live streams. So my goal here is we're going to have a quiz this week, so I will have another live stream coming up, probably on, on Thursday. So definitely be on, we'll do a live, no, it's probably not going to be till next week. Never mind, I'll give kids time to make it up. So we'll probably have a live stream next week, and then I'll probably have a quiz live stream, a homework live stream, and then the week after that, we'll probably do one more live stream, and then we'll be done with polynomials and then getting into the trig. So for those of you that are, going to be starting to trig, I will be continuing the same exact format up until then. So either way, guys, obviously, unfortunately, I haven't found a better way to type in questions, unless obviously you're a part of the, Patreon that I'm letting students know that you can let me know your questions, and therefore I'll go ahead and answer them the best I can. And so, but for right now, if you just have a question, type it in. But I'm going to go ahead and sign off, and I will be back in 10 minutes. So adios, everybody. I will see you in the next stream.